We're here at the Space Telescope Science Institute in Baltimore, and believe it or not, I used to work here back in the day working on the Hubble Space Telescope. Well, today I'm back because we're going to visit the Mission Operations Center for the James Webb Space Telescope. So come with me, and let's take a look and see how Webb gets flown.
Get a file.
So here we are in the James Webb Space Telescope's Mission Operations Center, and I'm joined by the Mission Operations Manager, Ken McKenzie. Ken, thanks so much for showing us around.
You're welcome. Glad you could come visit us today.
This is great. So this is the cliche is the room where it happens, but is this kind of like the room where it happens, right?
Yeah, we call this the flight control room. It's where all the commands that are transmitted to the spacecraft are sent. All the telemetry that comes down, all the science images come through here first. They aren't processed here, but they arrive here first and then they're distributed to the different subsystems that process the data.
So this is where the telescope is effectively flown, for lack of a better phrase, right?
Yep. Yep. Anything that is sent to the spacecraft is originated from this room, transmitted out to the Deep Space Network, and uplinked to the spacecraft.
You know, it's funny when we think about these sort of operation control centers, like we always see like these dark rooms with all these rows of computers, but this is an office suite, isn't it? And you have windows. I mean, look at that.
We took advantage of the space, made it as clear and revealing as we could. The traditional Goddard spaceflight control centers are in a darker room, and you don't get to see the ambiance of the outdoors, so it's very nice. So it's a large room now that we no longer utilize the space for, just because of the number of people that were required to do the deployments as well as the commissioning activities. So we're down to 3 operations people routinely every day for all the launch, deployment, and commissioning activities. All positions in this room were full. All positions in the engineering room were full. So at any one time, we had probably 30-some people on site, operating and preparing to do the deployment.
Wow. It was really crowded in here.
Yeah, it was. And, as you very well know, we were in the middle of COVID. So we had to take a lot of care and precautions. We had plastic dividers and, masks and all that fun stuff. But we pulled it off. It was successful.
So what are these different stations then? I mean, I know you said you're down to 3 people, but what do all these different stations represent?
Well, for the first 30 days of the mission, we had our NASA project manager on site 24/7 to oversee all the activities. There's always lots of reporting, lots of layers of management, if you will, that are looking for status and things like that. So we had a project manager, we had an operations manager, and an operations engineer, just because of the volume of communication and paying attention of the different subsystems and activities that were taking place. In the middle row there, we had what you call the timeline coordinators. Basically, their job was to keep us on the right path. If you can envision a 6-month campaign of activities that worked 24/7, it was a very time-consuming job to make sure we were on the right commissioning steps and to verify that the next ones were ready to go. So that's what their job, middle row, was for the first 6 months. In the front row, we have what we call our controllers. We have a command controller, and their job primarily is to issue the commands. They follow the scripts that we have laid out to send commands to the spacecraft. We have an operations controller. The operations controller's job is to oversee the command controller. We have a 2-step process, whereas you have send a command, you want a verification. So we have electronic, computer-based verification, but also human-in-the-loop eyes to make sure that what's going out is, in fact, what we want to go out.
And that's sort of like your last sanity check before it actually flies up to the telescope.
Yep.
Wow.
So once it leaves here, it's gone. There's no change in it.
So from here, it's going where? It's going, obviously it doesn't go directly to the telescope. There's no big antenna on top of the top of the building here.
No, we operate from the Deep Space Network, which is 3 ground-based antennas throughout the globe. However, the central control center for the DSN is located at JPL, which is out in California.
Okay.
So we have transmission through them. Then the commands are sent to the individual ground station, depending on where we are.
I guess the DSN antenna that actually talks to the spacecraft is on the night side of Earth at all
Typically.
times. Yeah. Right. So can we take a look at some of these workstations up close? I don't want to get in the
sure.
So, okay, great.
The sensor to So normally in normal operations, we're using.
So we have the command controller, and actually we're doing some training today. But what he's looking at, and I'll let you talk if you don't mind that, but he's got telemetry pages that basically capture each of the spacecraft subsystems that allow you an insight as to how they're operating, how they're performing. You'll see a lot of green displays here, and the green typically in spacecraft command and control is good. Yellow gets a little hairy, and red is bad. So we like to see all the green that we can see, and then gives us the insight as to what the operation.
So what are some examples of the telemetry points that are up on the page?
Matt, why don't you go ahead and show them?
So let's see, what we're doing right now is pinging basically an aliveness test on Find Sun Sensor 2. Normally we use Find Sun Sensor 1. If we go into any kind of a safing event, we might switch over to the second sun sensor. So basically we're just checking to make sure it works. And so the command I just sent was to enable the sun sensor 2, and you can see right here this telemetry point tells me that it's enabled. And I just sent the first ping, which you can tell there the X and Y coordinates. So this is the coordinates in X and Y on the detector where it thinks the sun is. And so what should have happened when I pinged it is that it should have updated, and it did. So I just opened a plot of the X coordinate, and you can see this is what's its value. I pinged it and it updated, so the sun has moved since the last time, or not the sun, but the spacecraft orientation has moved since the last time we pinged it. So that's what we expect to see. So the sun sensor seems to be working correctly, but to be sure, we're going to wait about a minute and send one more ping after I let it go. Okay. So I'm going to wait about a minute, send another ping, and see if we get another slight, maybe 1 pixel update on the sun position. And if it is, then we'll say it's good. We'll disable the interface for the sun sensor 2 and continue on.
So we just saw you send a command up to the James Webb Space Telescope.
Yep.
And it responded in real time. We just saw that. How cool is that? That's really
Takes
cool.
about 7 seconds for the light travel, but
Hey,
in real time, yeah.
Well, you have something
Pretty
to do
fast for a million miles.
Pretty fast, yeah.
Yeah, it's not bad. Yeah, that's fantastic. So this is what it's like to fly a spacecraft 1.5 million kilometers from Earth at L2.
Yep.
And where's the joystick? Do you have the or is there like a throttle?
It's right here.
Oh, is that?
There's the joystick.
Oh, it's an icon. So
yeah, that actually is what allows me to take control of a given config. So only one person can be sending commands at a time. So you have to actually take control of the config, and yeah, you do that by that little joystick.
But there's
no actual
pointing
joystick.
of the spacecraft.
Yes.
It does that itself.
Right. OSS, the onboard scripts direct the pointing to the various science targets. You
So
know,
what is the Find Sun sensor?
So it's part of the attitude control system. So it's basically looking for where the sun is. There's 2 of them. And it uses that information. It takes that into account to determine the spacecraft's attitude in space.
Yeah, in many ways, the sun for us is like the North Star for early navigation.
Yeah.
It's always, the spot. And if you know where the sun is, then you know where you're supposed to be pointing.
Right. So what are these pages up here on this main display? What's going up here?
So in summary, this is our
so
mission
sun
clock
sensors,
display. As you can see, it tells us when our upcoming LOS is loss of signal, AOS is acquisition of signals.
Okay.
So it tells us how long we've got left in one contact, when we're going to get the next contact. This is our visualization tool, and basically it's reproducing where we're pointing in the sky. So those are the targets that we see, and this is the visit. We have what we call onboard script subsystem, which is an event-driven operation. So we uplink these to the spacecraft, and they're basically just individual targets and/or observations that the spacecraft's going to take and send down to us.
Okay, so the visits are effectively the observations.
Effectively.
Right. That's
There's a lot of other information contained in a visit, of course.
right.
But
Like all the overhead and the
the
filter
slew
rotation.
targets and where we're going in the sky and the guide stars are placed that.
Of course, right.
But that's the primary observation.
Package. Right. Yeah, right. So what's it like? I mean, you get to do this amazing job. Are you kind of used to it now, or are you still in the, I can't believe I'm doing this? What's it like?
Well, it's different. Some days you get up and think, oh man, what are we going to discover today? And other days it's like, okay, we're in a weekly cadence and things are fairly normal. No anomalies, no problems to address. So that's, you know, some days that's nice. But again, as we mentioned earlier, we had a long, hard grind to get to where we were.
Yeah.
It was a big challenge for testing. It was a big challenge for review boards and for, you know, just the whole scrutiny that this large of a program is basically under the microscope. So we worked hard getting to launch. Then we had to start commissioning and start the deployment activities that, again, it was a different grind, but a grind nonetheless. So when we got to July, August, and things were, you know, kind of eased off and we had to our early release stuff and things were going well, it was like, we can, you know, kind of let our guard down.
Finally breathe a little bit more.
Yeah.
All these stations, all these people who, you know, each workstation just represents
Person in some respects.
several persons, right? Yeah, you know, from the design, the development, the implementation, to the on console, to the post, and you get to be in charge of it.
You get to be into it every day.
Yeah, help out that.
That's
It's
so
awesome.
cool.
Okay, thank you so much
Very welcome.
for this tour.
Glad you guys came
Really,
and
oh,
appreciate
man.
the time that we could share.
So how cool was that? We got to see how Webb is flown, how it's operated, and I gotta admit, it's just kind of cool coming back and seeing how the place has changed after all these years. And I want to thank you so much for watching, and I couldn't be doing this without your support, and especially with the support of my patrons. And I want to thank all of you guys for helping to keep Launchpad Astronomy going. So if you like to stay on top of what's going on with Webb, as well as a few other things happening in the universe, well, please make sure you subscribe and ring that notification bell so that you don't miss out on any new videos. Until next time, stay curious, my friend.